Alright, so this video is about the remainder theorem, among some other stuff. But first thing is this. The remainder theorem is this theorem. If P of x and Q of x are both polynomials, then the remainder of P of x divided by Q of x is equal to P of any zero of Q of x. So that's what the remainder is going to be equal to. So this is how it actually works. It may not make much sense like it is, so we're going to put it to use. It's going to make a whole lot better sense. I'll get this copy as a note though, because I'm about to erase this screen. This is the example. So let's find the remainder of this polynomial divided by this polynomial. And this looks like a synthetic division question to me, because I can actually use synthetic division for this. So I will go ahead and do that. Start with brackets. Outside is positive 2. The numbers are squared to first constant, so it's in right order. So 6 to negative 17. Alright, so 6 comes down. 2 times 6 is 12. Add these, you get 14. 2 times 14 is 28. Negative 17 and 28 is 11. Remainder is 11. So the answer is remainder is 11. Now, let's say that on the top there, that was P of x. On the bottom, that was Q of x. So if that's true, then P of x is equal to 6x squared plus 2x, subtract 17. And Q of x has a 0 at positive 2. Right? Because positive 2 makes the bottom 0. So let's try this. P of 2. That's a 0 of Q of x. That means 6 times 2 squared plus 2 times 2, subtract 17. So this is 6 times 4 plus 4, subtract 17. 6 times 4 is 24 plus 4, subtract 17. So this is 28, subtract 17. This is equal to positive 11. Notice how they're the exact same thing. That's the remainder theorem. It basically says that if you took the 0 of the bottom part, replaced it into these numbers, it's going to be equal to the exact same thing as had you taken synthetic division and found the remainder. That's essentially what the remainder theorem says. So, that being said, I'll copy to anything you didn't already know as a note, because I'm about to erase the screen now. Alright, so pause the video, copy to anything you didn't know, and we'll go forward. Alright, so the direction says use synthetic division to find f of negative 3, given that f of x is this. So basically, if you're going to use synthetic division for it, you need the synthetic division brackets. And basically, out here is always a 0. We usually get the factor, and we switch the sign on it and make it negative, positive, whatever. But if this is already the 0, this is already the number, you don't change the sign on it, it's just negative 3. Alright, and then, keep in mind, I could have found f of negative 3 by plugging in negative 3's all those. If I didn't have a calculator, I might not really want to do that, because the numbers might get pretty big. Let's try with synthetic division. So the numbers are, they're in the right order, so it's 3, 2, 1 constant, so everything's in a good order. So I don't have to plug in the zeros. So this is 8, 7, 2, and 4. So the 8 comes down, and you get negative 3 times 8 is negative 24. Add these, and this is negative 17. Negative 3 times negative 17 is a positive 30 plus 21, so that's 51. Add these, you get 53. And then negative 3 times 53, that's 150, subtract 9. Well, plus 9, so anyway, negative 159. So this adds up to negative 155. So apparently, f of negative 3 is equal to negative 155. I could check it with my calculator just to make sure. Probably would. I'm pretty sure this is what it is, along with all the math is right. All right, going forward. All right, this is a pretty important note. The note is, if the remainder of P of x divided by Q of x is equal to 0, then Q of x is a factor of P of x. All right, it's really nice to note. I'll copy that down someplace. It's one of the most important theorems we learned this year in math. So basically what that means is this. We can use this factor polynomials better, or find other zeros using the fact that we have one zero or one factor of it. So this is the example. All right, so the question is x plus 3 a factor of this polynomial? All right, so one way we can prove it, you already know, we could just factor this and see if x plus 3 came up anywhere as one of those factors. You could do that. That's pretty easy. Wonderful. This is another way of doing it, though. If that is a factor, the remainder of dividing this one by this one will give me 0. So if I took the 0 there, the 0 there is negative 3. And these coefficients are 3, 2, 1 constant. So coefficients are in the right order. So it's 1, 3, negative 4, negative 12. All right, so the 1 comes down, and then negative 3 times 1 is negative 3. Add these and it's 0. Negative 3 times 0 is 0. Add those and it's negative 4. Negative 3 times negative 4 is 12. Add those up into 0. Remainder is 0. It's really, really nice to know. So if that's true, yes, x plus 3 is a factor of x cubed plus 3x squared subtract 4x subtract 12. Why? Because remainder is 0. So that's 2. It's got to be a factor. No doubt about it. Actually, we can find other factors now. If I finish this, this is now, it started off cubed, so my answer is squared. So it's 1x squared plus 0x subtract 4. So that's more simply written as x squared subtract 4. So if I saw x squared subtract 4, I could factor this. It's x subtract 2, x plus 2. These are my remaining factors. Remaining factors. All right, so I could find other factors using the fact that that was a factor. I can go ahead and finish factoring that. Or again, you could have factored that in the very beginning using the fact that it was factored by grouping. However, we will eventually see some, though, that won't be factored by grouping. And you will have to use the fact that you're given a factor or given a 0 to find the other remaining factors. All right, so anyway, that's a note. And I'll copy anything you didn't already know as a note. Moving forward. Okay, so given x plus 4 is a factor of P of x, and P of x is equal to this, find the remaining factors of P of x. Now, true, I think you can factor this by group pretty easily. I'm going to do it, though, using the fact that we can use symbolic division here. So, what I know for certain is this is a negative 4, and the numbers for coefficients are 2, 8. It goes 4, 3. It skips by squared. So after adding, you plug in a 0 to hold its place. 2, and then 8 again. So from there, 2 comes down, and it's 2. Negative 4 times 2 is negative 8. This is 0. This is 0. This is 0. And this is 0. And this is 2. Negative 4 times 2 is negative 8. And this is 0. So what I have now is, it started off as squared. So this is 2x to the third plus 0x squared plus 0x plus 2. All right, let's simplify that, make it look a little neater, and get all those zeros out. So it's 2x to the third plus 2. You may see this as factorable. You should definitely see this as GCF there, so you can factor that out. X cubed plus 1. Now you should build your rig. So, oh, this is difference of squares. This is a SOPs problem. So I could factor this using SOPs. So, I'm sorry, difference of cubes, different perfect cubes. I'm sorry, sum of cubes. So it's going to be x plus 1. And then square, opposite, product, plus square. So x squared, subtract 1x plus 1. These are the remaining factors. And I'll put a note somewhere around it so I know what I just found. I would say remaining factors of 2x to the 4th plus 8x to the 3rd plus 2x plus 8. And that's it. All right, so that's how I can actually find the remaining factors given a factor. I'm going to give you one more for you to try on your own, and then we'll be done talking about this. All right, so final example. Example says, find all the factors of h of x given h of x is this. Take a look at this. See if you can factor this by grouping. Pause the video and see if you can actually factor this by grouping. Probably saw that you can factor it by grouping. So we've gotten to a place where we have no factoring techniques that will lead us to this answer. So we can't factor by grouping, can't use SOPs, can't use different squares, different cubes. There is no way we can factor this. However, it is factorable. It has factors. So in this case, we got to use other methods. The other method we have left, only method we have left is graph it. What I could do is I could graph this. I could find any zero there is to find on there. The more, the merrier. I could use those zeros to use symbolic division to break down this from to the 4th power to some smaller power and then factor it. And this is the process we're going to have to use. So I'm going to take my calculator. I'm going to graph this equation. And type it in. All right, so I'll type this entire equation into my calculator. I'm going to graph it. And I see that there are zeros, clearly because it's across the x-axis. It's kind of hard for me to see. I'm thinking this is 2, and I'm thinking this is -1. I really can't tell any of the others, though. So what I'm going to do is check that out in the table. And it looks to be at, let's see, -1 first. -1 is definitely a 0. 2 is definitely a 0. So I got 2 zeros to start with. So let's get that out of the way. So I know x equals 2 and -1. -1. These are 2 of my zeros. So the factors are x subtract 2, x plus 1, and some other stuff. And that's a 1, just for the record. All right, so from there, I'm going to use these zeros in symbolic division twice. So the first one is 2. So 6, 1, -22, -11, and 6. And you symbolic division there. So the 6 comes down, and it's 12, it's 13, 26, 4, 8, -3, 6, -6. 0 is my remainder. It's going to come 6x to the 3rd plus 13x squared plus 4x subtract 3. Taking this and using symbolic division again with my other 0, -1. So it'll be a -1 here. And the numbers are 6, 13, 4, and -3. So the 6 comes down, and it's -6. And this is 7. And this is -7, and this is -3, it's +3, and it's 0. So this is now 6x squared plus 7x subtract 3, which is about a trinomial that I can factor. I can actually try to factor this using the x game. It's -18 on top, 7. This is going to wind up being 9, and -2 works. So it's going to be x plus 9, x subtract 2, divide both of those by 6. So this is going to be x plus 3 over 2, and x subtract 1/3. So my final factors are 2x plus 3, 3x subtract 1, That's all I have. Good luck.